Overview on the algebraic identities under polynomials. Identity. What is an identity? It is an equality which is true for all values of variables. In the earlier classes, we have studied the simple algebraic identities. Some more we can look into, but these are the following four common basic identities which we have already studied. So the simple sums as shown in the examples 1, 2, 3, 4, they can be resolved by making use of these four identities. Let's look into some different sums based on identity 3. The identity 3 states that a minus b times a plus b is equal to a squared minus b squared. Looking into the first sum, it has four algebraic expressions. We need to find the product of them. If you look into the first two and combine the two first expressions, then you get the identity 3, like x minus 1 times x plus 1 gives rise to x squared minus 1. This resultant with the expression 3 x squared plus 1 once again will satisfy identity 3, giving rise to x to the power of 4 minus 1. So the fourth expression when multiplied with the resultant gives rise to x to the power of 8 minus 1. Let's look into sum number 2. It has got a similar construct. There are four different expressions. We need to find the product of them. The first two will adhere to identity 3. You need to find the resultant of it first, and then the resultant with the expression 3. Once again, it will satisfy identity 3. Once again, you need to find the product with the fourth expression and you get the final answer. Looking into sum number 3, there's a slight variation wherein the first two expressions are looking alike, but the only difference is they have to be rearranged. So on rearranging them, we get the first two terms looking similar to identity 3, giving rise to the resultant 1 by 4 a squared minus 9b squared. This you need to find the product with 1 by 4 a squared plus 9b squared. Once again, it satisfies identity 3, where then you can substitute in the identity and find the resultant. Looking into sum number 4, this also has to be rearranged because the first expression is raised to the power of 3, whereas the second expression has a power of 1. If we remove the power of 3, it can satisfy identity 3. So what we need to do, remove or find the product of m plus 1 by n times m minus n by 7. The remaining m plus n by 7 squared, you need to multiply with the expression that can satisfy identity 3, and then you get the resultant. Now let's look into some sums which can combine more than one identity. These examples combine identity 3 and 1 or identity 3 and 2. So let's look into each one of this. Looking at an expression, if you need to find the product, the first thing you have to notice is whether the terms in each one of these expressions are the same terms, or it could be a square, or it could be a it could have just been multiplied by a number, say 2, wherein you can remove 2 and make both the terms, both the expressions look alike. So in this particular sum number 5, looking into the terms in the first expression, it is x, y by 5, 1, which is similar to the one in expression 2. Only that the operators, they are different. So what we do, you just remove a minus so that it satisfies the identity 3. Then you go by the identity and get the resultant. So from step 2, it shows x squared minus y by 5 plus 1 the whole squared. This you need to resolve making use of, it is very much clear that identity 1 will come into picture here. So making use of these two identities, you can solve this kind of problems. So the next sums are based on identity 3 and 2. Looking at the terms in each of the expressions, they are like terms, only the operators are different. So making it in a way that both the expressions are the same, will make it suitable for identity 3 and then resolve using identity 2 to get the resultant. The sum number 7 is also of the similar construct, where this sum is a little bit different, meaning the first term has 1x extra multiplied into each one of the terms in expression 1. So just remove one x outside and make both the expressions look similar, and then apply identity 3 and identity 2, get the resultant. The fourth one is also a similar one, wherein only the operators differ. Remove the minus and make it look similar so that it can satisfy identity 3, and then make use of identity 1, get the resultant. The previous slide we have seen the sums wherein the terms in each one of the expression are the same and the operators differ, in which case the first idea that you should get is that it can relate to identity 2 now, or identity 3, sorry. Now let's look into these problems and find out how to identify which identity will work out. If you look into this particular sums, like it has an addition and a product, like x plus y is given to be 12 and xy is equal to 32. The very first identity which should come to the mind is a plus b the whole squared, which is identity 1. So just replace with the given values and very easily we can get the resultant. So some similar sums could be as mentioned in sum number 2. Now a little variant to this sum wherein it can make use of the same identity 2 is sum number 3. 9x squared plus 25y squared is equal to 181 and xy is equal to minus 6. In sum 1 you have seen it is x plus y, here it is x squared plus y squared, but still the identity 1 which states a plus b the whole squared is equal to a squared plus b squared plus 2ab. In this particular identity we can very well replace all these values and get the resultant value. You can get similar sums like 4x squared plus y squared is equal to 40 and xy is equal to 6. And let's look into some sums based on the identity 2. X by 2 minus 2 by 5 times 2 by 5 minus x by 2 minus x squared plus 2x. So there is it's a quadratic expression wherein the operators, it has a negative sign, so it gives a clue that identity 2 could be very well used. And there is a term which has a degree of 1, and then you have one more expression which is a product of 2, but only the operators are different. So just rearranging them so that it will adhere to identity 2, and then you get the resultant as it is given here. In the previous slide we looked into some of the sums where it involves addition of two variables or addition of square of two variables, wherein it gives an idea that identity 1 can be used. There are some other formats for which the identity 1 could be used, like sums given in this particular slide. The first sum is 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ca. This particular sum just involves the rearrangement of the terms which can satisfy identity 1, and hence you will get the answer. Same with sum number 2. You just have to multiply the entire expression by 2 and then rearrange as per sum number 1. So the given sum is, we need to prove A is equal to B is equal to C. We'll reach till the final step where it says A minus B the whole squared plus A minus C the whole squared plus B minus C the whole squared is equal to 0 is the expression or the equation given in this particular sum. Now, we will say A is equal to B and A is equal to C, B is equal to C. Why? Because from the expression A minus B the whole squared plus A minus C the whole squared plus B minus C the whole squared will be, if it is equal to 0, it means each one of these terms like A minus B the whole squared should be equal to 0, A minus C the whole squared should be equal to 0, B minus C the whole squared should be equal to 0. Only when all the three individual quantities are 0, only then the addition of all these three will be equal to 0. So we can prove the what is needed in the question. This kind of questions should not be confused with the identity. There is some other identity which we will look into the next video. That is the identity for the square of a trinomial. If you look into the pattern, it will look very much similar to the sum which we just resolved using identity 1. These identities, that is a square of a trinomial, is a different case. If you look very carefully, the operators for the terms like 2ab, 2bc, 2ca, either all three are positive or any two are negative. Only in that case we will go for the identity for the square of a trinomial. Otherwise, if all the three hold a negative sign, then we make use of identity 1.